All right, today we're going to start talking about imaginary numbers. And imaginary numbers come from this situation. One of the ideas, anyway, is that if I've got this function, x squared plus 1, and we know what that function looks like, that's a parabola that has been moved up 1 unit. So that means it's not touching the x-axis anywhere. That means there are no real solutions. There are no real solutions because if I tried to set that quadratic equal to 0 to find the x-intercepts, if I subtract 1 from both sides, I have x squared equals negative 1. And we talked about extracting the square when we solved quadratics. If I took the square root of both sides, I have the square root of negative 1, which we cannot do. That is where we get our definition, the square root of negative 1 is equal to I. All right, I by definition is the square root of negative 1. All right, so if I know that I is the square root of negative 1, then I also know that I squared is just negative 1. And we will expand that idea with the powers of I even more. This also means that I know that I cubed is just negative I, because it is this times this, all right? And I also know that I to the fourth is positive 1, because it's I squared times I squared. This pattern repeats in 4s, just like that. And we'll talk some more about that in a later example, all right? So that also brings up this idea of what is a complex number. A complex number has a real part and an imaginary part, like 5 plus 3i is what we call a complex number. It has a real part and it has an imaginary part. Okay, this 5 is the real part. The 3i is the imaginary part. All right? So, that being said, we're going to start working with some operations with them today, just to get us started. So, if they ask you to do operations with these, the operations work just like what we've always done. If they tell you to do the operation and put it in standard form, well, standard form is this right here. That's standard form, all right? Real part plus or minus an imaginary part, okay? So keep that in mind. So they could give you something like this. It's very easy. 3i minus negative 2 plus 7i, something like that. So it's really just like algebra, basic algebra, combining like terms. Distribute my negative through, and I have positive 2 minus 7i here. Then I have this 3i, combine my like terms, and I've got that this is 2 minus 4i. And that is in standard form. Now, they could get tricky, and they could say, okay, put 17. They give you just the number 17 randomly, and they say write it in standard form. Well, that would be 17 plus 0i. There's no imaginary part, so we just make it 0i. All right? They could also ask you to multiply two binomials. 5 plus 2i times 3 minus 4i, something like that. And if they ask you to multiply two, those are actually complex numbers together, we just do it with FOIL. All right? So we just follow our regular FOIL plan. 5 times 3 is 15. The outside terms are negative 20i. The inside terms are plus 6i. And the last terms are minus 8i squared. Now, this can be cleaned up a little bit because of what I just told you on the first page. I squared is negative 1. So I can replace this thing with a negative 1. So now I have 15, combine my like terms here, minus 14i plus 8. Because that I squared is a negative 1, so my final answer would be 23 minus 14i. All right, and we're good. Okay. So the other things that you're going to be doing some of is some simplification that does involve some radical work. Before we do that, though, let's just remember about distributive property. If you see this problem, it's pretty easy, but I just wanted to make you aware of it before we move on to the radical work. You just do distributive property. Distribute, distribute, and you have 40i plus 24i squared. Remember that I squared is negative 1. So this is actually negative 24 plus 40i. All right. Now, the last thing. You're going to have some problems where you have to simplify radicals. All right, this is example number 5. Let's say they give you 5 plus the square root of negative 40. All right, and notice that the negative number is under the radical. Okay, here's the rule. Take the I out first. Always. So before you ever start simplifying this thing, we're going to make this 5 plus the square root of 40i. Because we know that I is the square root of negative 1. And then we can simplify our radical. We can make this the square root of 4 times the square root of 10 using your root sheet that we did like we did earlier in the year. And that would be 5 plus 2 square roots of 10i. Okay? And one more. Let's say that we have the square root of negative 3 times the square root of negative 12. Well, you do not multiply under the radical and make that the square root of 36. You have to take your I out first. This is the square root of 3i times the square root of 12i. You have to take the I out first, always. So now I have the square root of 36 times I squared. And we know that the square root of 36 is 6, but we also know that I squared is negative 1. So my answer here is negative 6. See, if you would have just multiplied underneath here and said this was the square root of 36, you would have said the answer is 6, and that's wrong. Okay, you have to take the I out first. And we will stop there for today.